Hello everyone, very good evening all of you. Very good evening once again. Alright guys, I hope that you can hear me properly. आज का topic of discussion है photochemical reactions, right? And yes, there are a few previous year questions that I have taken today. थोड़े से PYQs लिए हैं and along with that we will be doing some examples from the book. ठीक है, because I find that doing a little bit of detailed practice is going to give you more clarity on the concept. ठीक है, तो PYQs भी करने वाले हैं और book के question भी करने वाले हैं. Okay, very good evening युवराज, अथर्वा, दिशा, शुभदीप, everyone welcome. Dipanshu, good evening all of you once again. Okay, so yeah, let's begin without any further delay. First of all, I have taken some old PYQs. After doing some previous year question, we will jump into book questions. ठीक है? Yes, Logesh, Prasad, Hima, welcome all of you. Good evening once again. चलो पहले easy question से start करते हैं, PYQ से start करते हैं. So this is a previous year question. Two-step conversion of 7-dehydrocholesterol to vitamin D3s proceeds through. Yesterday questions were awesome. Thank you, Dipanshu. Thank you. I just hope that whenever you give the exam, just go through all of them, revise, and you have already got a lot of knowledge of organic. Organic तो मैं करवा दूंगी. इसके just बाद में inorganic का भी शुरू करेंगे. Let's see how it goes. All right, yeah. First question. बहुत easy है. All right. OH is missing in the product. हाँ, OH को कुछ नहीं हो रहा है. OH is still there. Nothing is happening to OH. Only in this ring there is something happening. So what is that? Yes, guys, I hope that you have revised a little bit of photochemistry. That is going to be good enough. Yes. What do you think? Good evening, Satyanarayan. Welcome. All right, guys. ये बहुत पुराना question है, but ऐसा तो है नहीं that old questions we all know we have all done all the old question. That's why we have it here. It is still tricky. What kind of a ring opening is this going to be? Yes, Logesh, you are saying C. All right. To just guess one thing. Two-step conversion. See, this dehydrocholesterol to vitamin D3 takes place in our body also, right? And this reaction takes place in the presence of light, right? So it's not going to be thermal, guys. C और D दोनों गलत है. Okay, so this is a photochemical reaction for the formation of vitamin D3. Now, if you just imagine, see, where are these methyls and hydrogen? We want to bring this ring like this. ये कहाँ पे है? ये methyl, this is above the plane and this is also above the plane, both of these hydrogens, both of these group. Let's say I'm imagining it like this, one methyl above and on the other side this hydrogen is above. ठीक है? I want to open this ring in a conrotatory manner, let's say. Conrotatory कैसा होगा? Both of them are moving in the same direction. If that is happening, see, on one side there is this hydrogen and the methyl and on the other side we are having these alkyl group. तो ये alkyl group का भी सोचना पड़ेगा, isn't it? How are we going to think about these alkyl and groups? See, we have opened the ring like this. This ring is this is a ring part. Okay, this is a ring residue, both the sides. It is going outside and the methyl is going inside. This ring, if I open it like this ring is going to go inside, hydrogen goes outside. ठीक है? तो what is possible geometrically? ये जो ring है ये अपनी अपनी जगह पे रहना चाहते हैं, right? It is not going to be a disrotatory ring opening. Disrotatory होने से this goes here and this goes here. Got it? Then both the rings. See, if this methyl is falling outside, तो ये ring distort हो जाएगा. We don't want the ring to get distorted. That is why we are putting both the rings like this, such that they are going to be in this way that they are not distorted. So, अगर distort नहीं करना, if we don't want to distort the ring, it is going to be a conrotatory ring opening reaction. Once you open this ring, once it is conrotatory ring opening, it is going to give you this kind of, see, there is a CH3 over here. It is going to give you a CH3 inside. Let's say I'm putting the CH3 inside over here. ठीक है? ऐसा आ गया. And on this carbon you have a hydrogen. So this is how the ring opening will look like. Now thermal anterafacial 1,7 hydrogen shift. So do you remember 1,7 and 1,3 were similar, right? In the thermal condition, they are going to be both anterafacial. Just that 1,3 anterafacial is geometrically not possible, like it's not very far away कि इस hydrogen को या कोई भी एक group को कैसे transfer करवाएंगे, geometrically not feasible, but 1,7 is feasible thermal anterafacially also. So what will happen? This CH3 is going, we are just going to write a hydrogen like this, 1, 2, 3, 4, 5, 6 और ये आ गया 7th carbon. So ये 7th carbon पे jump हो जाएगा and the pi electrons are going to shift like this, such that you are going to get a molecule like this. This hydrogen has shifted over here on the 7th position. Okay, so it is going to be a photochemical electrocyclic conrotatory ring opening and thermal anterafacial 1,7 shift. Okay, B is the correct answer. ये पुराना question है. Just go through this. It's very simple. Okay, we will move onwards. Nothing has happened to the OH. It is still there. The only reaction is there is in this part. Yes. आ जाओ. दूसरा question. Again a PYQ. Major product formed in the following photochemical reaction is. Alright guys, see. Tricky but not so difficult. Major product formed in the following photochemical reaction. Should the tertiary butyl groups, are they supposed to be like this or they are supposed to be like this? Where is it going to cause minimum repulsion? Good evening, Yash. Prismane intermediate. Good evening, guys. Good evening. Welcome. Sorry. So basically, guys, D nahi hoga because once you see that there are two very big tertiary butyl groups which are exactly like this. See, it's a four-membered ring, and you cannot have these two bulky groups crowding over each other. D cannot be the correct answer. You can put two of these tertiary butyls like this, all right, but then in this option, option number C, a four-membered ring, two four-membered rings are connected, they cannot have a trans junction. Is it geometrically possible to have a trans junction? Very strained it will be. ये भी wrong हो गया. फिर क्या करेंगे? Again two tertiary butyl groups are coming together. भले ही trans or trans junction, again very bulky groups, trans junction not possible. A is possible. A कैसे possible होगा? When we are actually in the presence of light, when we are actually opening up these two and causing a reaction between these two carbons. Okay, that is possible. Cyclization में ये दोनों जो group है, they are going to come and form a bond. See, if we are finally making a bond like this, ठीक है? It's more like the Devers benzene. अगर ये finally ऐसे बनेगा, then these two groups, these two tertiary butyl groups, they are far away from each other, and this tertiary butyl is syn with the hydrogen. So this is the most stable possibility out of all of these. So that's why A is going to be the correct answer. चलो A was correct. अब ये देखते हैं दूसरा वाला. Now what is happening over here? How can you possibly get one of these products over here? Try out the mechanism. Carbonyl है, light है, acetone है. What is the photochemical reaction of a carbonyl? Hello Rajiv, Anuj, welcome all of you. Yes, guys, try out this question. Very nice. Yes, guys, everyone answer. उसके बाद discuss करेंगे इस question को. A, B, C, D. You have 4 options. All right. So again, I said you are having a carbonyl. Carbonyl का photochemical reaction क्या होता है? Either it's a Norris type 1 reaction or a Norris type 2 reaction. All right, or a Paterno-Bucchi reaction. All of these. Can we try out Norris type 1? Can we try out alpha cleavage? Let's say we are breaking from this side because we want to also involve this double bond. That's why we are breaking from this side, isn't it? The hydrogen is still above. ऐसे करके ठीक है. What happens after the Norris alpha cleavage? What happens? There could be hydrogen abstraction, there could be decarbonylation, but we have one more possibility over here. इस methyl को ऐसे ही रहने देते हैं for a while, and we can open this pi bond from over here, isn't it? Pi bond को open कर सकते हैं. If we open this pi bond, you will have one pi bond like this and one radical over here. We can write it like this. Okay. ऐसा जरूरी नहीं है कि हम डबल बॉन्ड यहीं पे बनाएंगे. वी कैन ऑल्सो सी अदर पॉसिबिलिटी, बट फॉर नाउ आई हैव रिटन इट लाइक दिस. ओके, नाउ व्हाट हैपेंस? नाउ इन योर ऑप्शंस वी आर नॉट हैविंग अ डबल बॉन्ड ओवर हियर. तो ठीक है, डबल बॉन्ड को हटाओ, फिर नहीं लिखेंगे डबल बॉन्ड. नहीं है डबल बॉन्ड यहाँ पे. लेट्स कीप देम रेडिकल्स. What is the possibility? Possibility is I can connect, since I'm having a 3-member ring, I see a 3-member ring formed like this. I can connect these two dots and create a 3-member ring, and then I can also connect these two carbons. If I do so, see, it is going to be a little bit twisted. ये वाला जो carbon है इसको rotate करना पड़ेगा. You have to rotate this. How many membered ring is formed? 1, 2, 3, 4, 5 and 6. It is actually a 6-membered ring. How do I see that? इसको मैंने rotate करके यहाँ से connect करवाया है. So let's say this carbon is right over here. Let's say on the third carbon you are having 2 methyls, and then let's say to which carbon is it connected? It is connected to this carbon जो कि एक 3-membered ring ऐसे बना चुका है. All right, in this way, where the methyl is going to be on the top, isn't it? It's like folding the carbon and attaching both of these. So what does it look like? It looks like the first molecule. It looks like option number A, guys. We are not having D, not at all. Why we are also not having B and C, because if you want to make this 3-membered ring, then there is only one possibility. You have to connect these two ends of the 4-membered ring, and because of that the methyl is going to end up on this top carbon. ठीक है, तो थोड़ा सा ध्यान रखना है. Just be a little careful. A is the correct answer. Okay. All right, one more question from the PYQs and then we are going to discuss some nice book questions. Okay. Yeah, check this out. अच्छा है question ये वाला. A little bit lengthy, but easy. All right, correct match for the following transformation. 4 different transformations. What are their corresponding names? ऑलराइट गाइस, इस सेशन में एक भी क्वेश्चन का आंसर डी नहीं है. हाउ बैड इज दैट? यस दिशा, भव्या. ओके, D is not the answer for any question today. But let's check this one. Let's see. ठीक है, check करके देखते हैं. So first one, option number P. You are having alpha, beta, gamma. You are having gamma hydrogen. So let's CH2. Again, one more CH2 and then a CH2 and H. So this has a gamma hydrogen. This is absolutely going to be Norrish type 2 cleavage, which means it is going to match. P is going to match with the first one. हाँ, ये same reaction है. This is going to be Norrish type 2 reaction. Norrish type 2. ठीक है. So P is going to match with 4. P matches with 4. ठीक है. नहीं शुभदीप, अभी चेक करने दो, रुको. Q is going to be Norrish type 1 because decarbonylation is taking place. Okay, so this is Norrish type 1. So Q is going to match with 2. ठीक है. अच्छा, R और S का चेक करते हैं. See, this S1, this is a simple Diels-Alder reaction. So this is going to be 1. S is going to match with 1. ठीक है. Yes, yes, very good all of you, very good. S is going to be 1 क्योंकि diene ये वाला है. This is the diene and it is just reacting with a oxygen molecule. Oxygen is behaving as a dienophile. You got this. Fine. What happens in R? It is not so simple. R is going to match with 3. ठीक है. R is matching with 3 और आंसर आपका C ही है यहाँ पे. But how it is happening? Let's see. So first of all, photocycloaddition followed by a Diels-Alder reaction. What is a photocycloaddition? And you don't even have a diene over here. Benzene तो diene जैसे behave नहीं करेगा, but benzene can behave like this. In the presence of light, it can give you a 2+2 cycloaddition. So this is the photocycloaddition it is talking about. Right, you got it? Now, this part of the molecule is going to behave as a diene to another Diels-Alder reaction, and that's why you get this side of the molecule. So first there is going to be a 2+2 cycloaddition, and then there is going to be a 4+2 cycloaddition. ठीक है? Yes. Yes, exactly. Anuj, ऐसा नहीं है. Pericyclic reactions are possible in both in the presence of heat and light. The mode changes. It's going to be suprafacial or anterofacial, that changes. लेकिन pericyclic reactions are possible. ठीक है. तो Diels-Alder reaction will take place in the presence of light. लेकिन पहले यहाँ पे 2+2 होगा. First there is a 2+2 and then there is going to be a 4+2. Okay, so your answer is option number C, guys. It was easy. Yes, sensitizer is confused. What is a sensitizer, Prasad? It is nothing but oxygen is a homonuclear diatomic molecule. That is, it is non-polar. So any molecule which is non-polar, it faces some difficulty in absorbing the light. So sensitizer is just helping the molecule absorb the photon to react. Okay, that is the role of a sensitizer, nothing else. चलो, अब आगे बढ़ते हैं गाइस. अब करते हैं बुक वाले बहुत अच्छे अच्छे वाले क्वेश्चंस. सो लेट्स सी बुक में क्या दिया है. सी, आई एम हैविंग अ टिपिकली बिग मॉलिक्यूल. So basically this was a Norborner known, but इसमें यहाँ हमने एक और कार्बन लगा दिया ऐसे. One more carbon over here and I have put 2 methyls like this. Now I want to do, yes, I want to react this molecule in the presence of light and in the presence of methanol. What is it supposed to give? क्या बनेगा यहाँ पे? And mostly, what reaction is taking place? Norris type 1, Norris type 2. Try this out, guys. No options. कोई option नहीं है. Try करो, क्या बनेगा? I will answer in 1 minute. These are very, very interesting questions. Book questions are always the most interesting. Yes, yes, it is going to be Norris type 1 because alpha, there's no gamma hydrogen, and we always want to break the carbonyl carbon bond from the more substituted side to give you the more substituted radical. Yes, yes, बिल्कुल कीटीन बनेगा यहाँ पे. बनाओ कीटीन बनाओ. How can you form the ketene? Exactly, yes. Ester formation through ketene. Very good. So, बहुत easy है. Norris type 1 reaction, it is going to break from the more hindered side, more substituted side. All right, because it wants to have a more stable radical. ठीक है. So, we are going to do the same. When there is a solvent present, then it is going to, guys, यहाँ पे solvent present है, polar solvent present है, which is a nucleophilic solvent. Okay, so what is going to happen? This nucleophilic solvent can give you an ester. That is why, what is the process after a Norris type 1? Norris type 1 हो गया, which is known as the alpha cleavage. ये हो गया. इसके बाद क्या होगा? इसके बाद में there is a intramolecular hydrogen abstraction by this radical such that such that it is going to give us one hydrogen over here, and on this side you have formed a ketene. Okay, now please understand, ketene will only form if you are having somebody to attack over this carbon. Otherwise ketene will not form. तो यहाँ पे ये oxygen attack कर सकता है. That's why ketene is forming. Okay, and that is why your final product is going to be an ester. I'm just drawing this part as it is. कभी question में rearrange करके भी लिख सकते हैं. Ultimately, this is just a ring. COOME. You have got. All right. Yes, very, very simple. Chalo, let's move onwards now. And we have to try out another possibility. So, what is going to happen to this molecule? ये शुभदीप, हाई चांस ऑफ फॉर्मेशन ऑफ कीटीन, क्योंकि कीटीन को भी अटैक करने के लिए पोलर प्रोटिक सॉल्वेंट ही तो चाहिए. बस यहाँ सॉल्यूशन लिखा है, नथिंग इज रिटन. फॉर एग्जाम्पल सॉल्यूशन लिखा है. व्हाट विल हैपन देन when there is no mention of the solvent? What is the fate of this reaction? Norris type 1. अच्छा, Norris type 1 कर सकते हैं because Even if there is a gamma hydrogen present, it is not accessible. So we can break from here, isn't it? ये रहा, ऐसे break कर दिया. So what was this? Alpha cleavage, Norrish type 1. Yes, Norrish type 1 हो गया. Then what? We can do a decarbonylation because hydrogen abstraction नहीं होगा क्योंकि ketene नहीं बनने वाला है. We are not getting any polar solvent, only solution phase is mentioned, right? So what can we do? We can remove a carbonyl from here. If we remove this carbonyl from here, we are going to have a ring like this. यहाँ पे एक radical आ गया. Do you think we should open this three-membered ring? Absolutely. This three-membered ring could be opened. अगर ये ring open होता है, then it is going to give us a two-sided double bond basically. Now you have a molecule like this. एक molecule possibility ये है, that is the bond, the alkene bond is trans. And since it is a radical, since there is rotation possible, we can also get this cis bond, isn't it? ये भी तो बन सकता है, but this is going to be the major one. This is going to be the minor one. What is the difference in both of these? About the alkene, it is the E alkene and this is the Z alkene. Z alkene minor. ठीक है? PYQ of last year, हाँ ये बहुत easy है. PYQ भी है, book question भी है, guys. Book से ही PYQ बनते हैं. So that's why making you do some book examples. Yes, they ask the steps. Okay, very fine. चलो इससे भी ज्यादा important है, थोड़ा सा और twist आएगा. When let's say I am adding a polar solvent, देखो this is the molecule. Yes, exactly. Trans is more stable, Shubhadeep. That's why it is major. ठीक है, चलो. ये रहा दूसरा molecule. Now again, we have light and we also have methanol. ठीक है. Chalo, we have light and we have methanol and that is going to give you two possibilities again, A and B. तो सोचो कि दो possibility क्या है and what kind of a reaction is taking place. It's a symmetrical molecule. Are we trying out Norrish type 1? अल्फा क्लीवेज तो करा दिया, उसके बाद क्या करें? Are we going to make the ester? No. Absolutely, we are not making the ester. Methanol is reacting. Yes, it is reacting. But how it is reacting, that is the question. बहुत ही अच्छा क्वेश्चन है ये. इसको आप चाहो तो आप स्टार मार्क भी करके रख सकते हो. चलो. So let's try out. Since you have done all the possibilities, so और क्या कर सकते हैं देखते हैं. This CH2 bond is going to be involved? I don't think so because this is very far away. Okay, अगर ये इस कार्बन पे होता तो बिल्कुल involve हो जाता, but it is far away. So since both the sides are same, we can break from any side. Let's say I'm breaking from this side. मुझे क्या मिलेगा? I will get a radical like this. This is CH2. CH2 is not going to be involved, guys. This is PH and this is CH3 as it is. अभी मैंने stereo change नहीं किया है. This is as it is. what are we going to get? Mixture of stereo हो सकता है ना. Carbene formed. अच्छा अब देखो, very very important. What happens when you are having a four-membered ring, when you are having a very small strained ring, और एक carbonyl present है यहाँ पे. We have done the alpha cleavage. This is Norris type 1. We have already done it. ठीक है. Now what is going to happen? Now the carbonyl double bond is going to break in such a way that it gives one electron to the already formed radical and one electron to the oxygen. What will happen? How is it going to look like? कैसा दिखेगा ये? ये देखो, it is going to look like this. Oxygen got one radical, but there are two electrons over here. Now is it having a negative charge? No, ये negative charge नहीं है. ये just electron density, आप ऐसा भी बोल सकते हो कि ये कार्बीन बन गया है यहाँ पे. It is a carbene. Okay. Now what happens? Now this oxygen is going to react directly with this radical to cause a ring expansion. Right? So how are we going to write the molecule? Molecule कैसा दिखने वाला है? बहुत simple है. I'm just going to not change the stereochemistry as of now. इनको हम ऐसे ही रखने वाले हैं. ठीक है. And there is this CH2 for example, it is going to form a 5-membered ring. और ये भी stereo हमने same रखा है. pH is above and CH3 is below. What happens is you can put this CH to this carbene over here and this oxygen like this. ये बन गया carbene. ऐसे लिख सकते हैं. Right? You write this carbene carbon over here and the oxygen, same possibility क्योंकि दोनों side जो है वो same है. ठीक है. Yes, so this is our molecule which has formed. Now what is going to happen? You are having methanol. So you know that a carbene is can insert between a OH bond. तो ये exactly वही करने वाला है. It is going to form a 5-membered ring as it is. This side phenyl, this side methyl. And what about this? It is going to attach OMe and hydrogen. But we are not sure about the stereochemistry. Con above hai, con below hai. That is why you are having two different products. Let's say in one of the products you are having methoxy above. Let's say in one of the products you are having methoxy below. That's why you are having a mixture of products because of the change in stereochemistry. Right? तो ये बहुत अच्छा question है, as I mentioned. Why? Because when you are having a very strained system, then ring expansion is possible by including the carbonyl oxygen going through this kind of a carbene intermediate. अब ये carbene बन गया, but again, this carbene needs a polar molecule. OH, NH, whatever is given to do the insertion, और जिस तरीके से ये add हो रहा है, कुछ addition के लिए चाहिए इसको. Okay, so you always need a polar solvent for this also, for this kind of an expansion. All right, ये concept भी recently पूछा गया है already, so be careful. And this is the answer. Let's move onwards to the next question. Yes, right? चलते हैं next question पे. Now we are going to see a molecule जहाँ पे alpha beta epoxy ketone I have taken. Okay, and I'm doing this reaction in the presence of light. When nothing is mentioned, no solution, no solvent, then assume it is happening in the vapor phase. Okay, so what can happen? अभी मॉलिक्यूल के पास एक्सटर्नल कोई ऑप्शन नहीं है, तो जो भी रिएक्शन होगा वो इंटरनल रिएक्शन ही होगा. ठीक है. Try this out, guys. Let's see what can happen. Can you follow a pinacolone type mechanism over here? कर सकते हैं क्या? Yes, yes, Pankaj, exactly. We are rearranging alpha beta cleavage through oxygen. So here we are not doing a Norrish type 1 cleavage. Norrish type 1 नहीं कर रहे हैं हम. What are we doing? We are breaking the epoxide first. Because you know epoxide is very sensitive. ठीक है, तो ये ही ज्यादा रिएक्टिव ग्रुप है, ये ही ओपन होगा. कहाँ से ओपन होगा गाइस? Are we going to open it on this side or on this side? Where the radical is more stable. So the radical will be more stable when it is in conjugation with the carbonyl. So we break the epoxide from over here. This side the radical is going to be more stable. So we break the epoxide like this. Got it? Rest of the molecule as it is till now. ठीक है. What can we do about it? I said कि अब कुछ ऐसा करना पड़ेगा जिससे this oxygen also forms a bond, stable bond, and this carbon also forms a stable bond. What can we do? What can we do over here? We can actually migrate this bond over here like this. If we do so, let's see how the molecule becomes. Okay, just 1 second. Okay, it is like this. यहाँ पे एक bond बन गया है. This is a bond and this is a carbonyl now. What just happened? Is it 1-2 migration of this bond? Is it ring expansion? Yes, it is. So ultimately, we are going to write a 7-membered ring. We are going to write a 7-membered ring connected with a 5-membered ring. Like this. Okay. ये दोनों carbonyl ऐसे आ जाएंगे. And अच्छा, sorry guys, in the question there is one methyl over here. I just forgot to write it. This methyl is also going to stay there. And it is going to be there on the junction always. और ये OH जो है, it is going to be on the 3rd position. ठीक है? Yes. So a ketone is formed after rearrangement. तो ये इस type का rearrangement भी possible है in photochemical reactions, right? Anything can happen in photochemical reaction. That's why we have so many possibilities. ठीक है? Yes. All right. Shall we move onwards to our next question? चलो फिर चलते हैं नेक्स्ट क्वेश्चन पे. Yes, Dipanshu, why not? There are awesome examples. बुक तो कोई खोल के पढ़ता नहीं है. I'm actually using mixed some from my notes. Okay, so you have two molecules like this, only with a difference of a methyl on the exo position. अब इनके जो products बनेंगे उनमें difference क्या आएगा? What is going to be the difference in product formation? First one cyclization, second one alpha beta cleavage. Why first one cyclization? Yes, yes, exactly, guys. See what is happening. Because of this methyl, the molecule is strained, and that's why first one, as always, see, first and second, both of these are going to pick out the gamma hydrogen which is present. Alpha, beta, and this hydrogen is on the gamma position. So both of them are going to pick out this hydrogen, and they are going to give us radicals. It is going to give us an OH and a radical like this. But the fate of these two radicals is going to be cyclization in this reaction, in the first reaction, that because of this methyl OH का और ये जो radical है दोनों इनकी proximity काफी close है. Because of close proximity, this is going to give you this reaction. Also, yes, also whenever you are having substituent on this alpha position, that is going to give rise to a greater percentage of the cyclized product. Okay, now there is just a hydrogen over here, and hydrogen is not very demanding. तो ये क्या कर सकता है? इसने बनाया radical यहाँ पे, it can break down in this way. ये break down कर सकता है. This is the alpha carbon, this is beta, and this is gamma. So it can break down in this way to give you this molecule. How does this molecule appear? ये एक 5-membered ring है, कुछ नहीं, एक 5-membered ring है. So this 5-membered ring, let's say we can write like this. There is one CH2 and there is another CH2 after tautomerism, क्योंकि ये finally tautomerize करने ही वाला है. So there are going to be 2 CH2, 1 carbonyl and a PH. This is the final molecule after this reaction. Yes, 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 exactly. वेरी गुड गाइज, वेरी नाइसली यू हैव ऑल आंसर्ड. और एक दो क्वेश्चन कर लेते हैं हम लोग, ठीक है? चलो, एक बहुत अच्छा क्वेश्चन है अगेन. सो वी आर हैविंग दिस मॉलिक्यूल, दीज टू मॉलिक्यूल्स वी हैव टू रिएक्ट. ये हमें दो मॉलिक्यूल रिएक्ट करवाने हैं, दिस एंड दिस, in the presence of light. How are they going to react? Paterno-Bucchi reaction, Satyajit? No, I don't think so. इतना इजी थोड़ी ना होगा. There is a methyl on this position. ये क्या करेगा methyl? Yes, Shubhadeep, nice. All right, guys, think a little bit more. Yes. So इसको हम क्या बोलेंगे? ये kind of enolization है. That if I'm using this hydrogen, तो ये एक तरीके से tautomerism ही तो हो गया. I'm involving this hydrogen. I'll be creating one double bond over here, and then all through the ring I'm going to rotate the electron. यहाँ पे भी enolization करा सकते हैं. So after the rotation of electron, the molecule is going to actually look like this. What has it become? In the presence of light, this is photoenolization. ठीक है, तो presence of light में ये बन गया diene. Now it can react with this. All right, now do you know what's going to happen? This is just a 4+2 cycloaddition. Now Diels-Alder reaction. ये तो हम कर सकते हैं, बिल्कुल कर सकते हैं. Okay, that's it. No pressure. Easy question. बहुत easy question. चलो. So, all right, guys. So, guys, काफी unpredictable है photochemistry, but when you just go through these kind of examples from the book, it brings you more clarity, isn't it? ऐसा जरूरी नहीं है कि हमेशा हमने 2 मॉलिक्यूल लिया तो वो हमेशा एक ही जैसे रिएक्ट करेगा. ठीक है, डिपेंड्स ऑन मेनी कंडीशन, aqueous phase, some polar solvent is present or not, or let's say uh, many different possibilities. एक लास्ट क्वेश्चन और कर लेते हैं. अच्छा, ये क्वेश्चन रह गया था इन द प्रीवियस सेशन. दिस वाज रिमेनिंग. DDQ ऑक्सीडेशन होने के बाद में इट इज गोइंग टू बेसिकली ब्रेक डाउन एंड अल्कोहल वाज गिवन. लास्ट में जो इसमें मैकेनिज्म आ रही है वो थोड़ा सा ऐसे है that what was the major product formed after this. I told you I will be answering in the next session. So here it is. You're getting this molecule. ओके, इसके बाद में थोड़ा सा स्ट्रेंज रिएक्शन है क्योंकि आयोडीन पे एसिटेट लीविंग ग्रुप है. दैट्स व्हाई इट इज गोइंग टू अटैक ओवर आयोडीन. ओके, अल्कोहल इज अटैकिंग ओवर आयोडीन बिकॉज इट हैज अ लीविंग ग्रुप. दैट्स इट, नथिंग एल्स. अब ये अटैक कर दिया, उसके बाद में ऑक्सीजन. See, it is going to be like this. One more acetate, one more pH. Okay, so now what is this methanol going to do? It is going to attack over the para position. So because of this group, it is inviting a nucleophile over here. Answer is B. इसका आंसर ये था, B था यहाँ पे इसका आंसर. ठीक है, और इसका मैकेनिज्म ऐसा होगा कुछ. ओके, बहुत इजी था ये वाला. अच्छा, एक और क्वेश्चन कर लेते हैं. जस्ट वन लास्ट क्वेश्चन. ओके, बेचारे पेटर्नो बुकी को क्यों छोड़े? Yeah, can you see the molecule clearly? It's an alkyne and a carbonyl. Okay, so what are we going to form over here? Okay, this is a OCH3. दिख रहा है साफ साफ? Diphenyl ketone and alkyne. What is going to happen in the presence of light? Yes, guys, this is predictable because in the presence of light, when a carbonyl and an alkyne is reacting, it is always going to move in one direction. तो ये easy है. Yes, Bhavya, you are going to find it in the Telegram group also. It's Jagdamba, pericyclic and photochemistry. Okay, just go through the examples from this book. It's awesome. Simplified. Okay. Yes guys, बहुत easy है. So what happens? You are doing a Paterno-Bucchi reaction, isn't it? And you finally get this product. You have a double bond over here. ठीक है. One side there is OCH3 and the other side there is a methyl like this. So what happens? ये क्या बन गया? Just like a oxetane, but it's not oxetane, it is oxetine क्योंकि ये double bond है यहाँ पे. Are we going to again ring open this in the presence of light? तो अगर वापस से यही break down करेंगे तो यही product मिल जाएगा. So we are breaking down in this way. Okay? ठीक है. इसको हम ऐसे open करेंगे तो क्या मिलेगा? Alpha beta unsaturated carbonyl. There is this methyl over here. ठीक है. So finally, yes, it's like a 2+2 cycloaddition and a reverse ring opening reaction to finally give you this alpha beta unsaturated ester. Okay. So whenever in a 4-membered ring you have this alkene, तो ये unstable हो जाता है, तो ये ring open करके ज़्यादा stable रहेगा. That's why ring opened. All right, guys. So these were some of the questions that I had to make you do. And there are many other questions, many other good examples in the book. If you are following the text, अच्छे से आपको और भी काफी सारे example मिल जाएंगे. PDF से भी आप पढ़ सकते हो. It is there in the group also. ठीक है, for pericyclic and photochemistry. Okay, guys. So I'm going to see you all tomorrow in another session, but tomorrow we are going to study heterocyclic. तो हम कल डायरेक्टली प्रैक्टिस में नहीं घुसने वाले हैं, पहले थोड़ा सा रिवीजन करेंगे बिकॉज ऑन दिस चैनल आई हैव पोस्टेड कंटेंट रिगार्डिंग मोस्ट ऑफ द रिएक्शन, बट हेट्रोसाइक्लिक के लिए ज्यादा मैंने पोस्ट नहीं किया है. सो वी विल बी फर्स्ट discussing some of the important points regarding heterocyclic reaction, and then in the next session, which is day after tomorrow, there we are going to practice. ठीक है. So tomorrow concepts. Okay. So chalo guys, this is it for today. I hope that you enjoyed the session. If you do, please like and share, and कल मिलते हैं. Keep practicing. Bye everyone. Take care all of you. Have a good night. We'll see you all soon. Bye bye.